Hello, Cougars. Welcome to this weekly overview video for the last week of this term and the last week in this physics class. It is the week of Monday, December 14th, 2020. So let's jump into our overview. For this week, we're going to focus on magnetism. And we're going to start off with some video notes on magnetism basics. Then on our Tuesday, we will have a Zoom where we'll discuss some of those basics, and you'll have a magnetism simulation that we'll get to experience some things that are unique to magnetism. Most of this will probably be familiar to you. For the most part, there will be a couple of new things. And then really the exciting part for me with magnetism is this idea of magnetic induction. And you'll take notes on that, and then you'll have a simulation on that. And on Thursday, we will have an end of course celebration and talk about induction so that you can be successful on your quiz. We will also on that day have a course feedback survey. So when you do that, please make sure that you're giving me your honest opinion about things, because it will help me in the future of the course. Friday is a catch-up day. So if you have some of you do need a lot of catching up to do, so use that day to get stuff done and turned in, but you should not be waiting for that day. So like I've been saying the last couple of weeks, do a little bit every day, do one, maybe two extra assignments every day, and you can get caught up, you can get your grade up. So please be working on that. All right, so let's jump into the week and get a little more specific. So these two videos are actually done by Bozeman Science. They're fairly short and sweet. Make sure that you are paying attention to these essential questions. If you can answer these essential questions at the end of your notes, then you will be well off. Notice I also have them broken up by two videos, okay? The second one is a little difficult because there's a lot of just observing what happens. So there's not like words to write down. You just observe and then write down what you observe, kind of a deal, okay? And make sure you get the right hand rule stuff written down, because it's stuff that you do with the right hand, because magnetism happens in 3D. Most of physics we simplify to one dimension or two dimensions, but magnetism just happens in 3D, and so we're going to talk about it that way. Okay. And it is 60 points. Then you'll have your Zoom with a pair deck where we'll talk about some of those things like magnetic field lines and how to draw those and that kind of stuff. Okay, for our simulation, make sure you log into Explore Learning, and it's the magnetism simulation. Okay, and open up the document. And like always, basically read the directions and do what it says, okay? So read through it, you kind of know the drill, and do your best to explain what happens. It's a really basic gizmo where you can take a magnet and put it on the, drag it to that line, and then you can drag like another magnet and you can put them together, and you can click play and see what happens. Okay, reset. So opposites attract. And then we can do like repel. We can put other things on there. Put 1 to 1. No, we got to replace it. So you're going to play with it and see what happens. Then you can do magnetic field lines and sprinkle filings. Okay, filings are like little base iron crumbs, if you like cookie crumbs, but they're iron. Okay, so when we put those on there, if we tap the table, what eventually happens, here, let's remove the copper here. Sprinkle. Okay. Eventually, the filings map out and line up with the magnetic field lines. Okay. So That's what your goal is to make the magnetic field lines appear. And so when I put 2 magnets on there, and you have to tap it a few times because it's in real life, it's not just happens immediately, but notice opposites attract, the field lines link up, kind of like the electric field, but realize this is a magnetic field, so it's drawn slightly differently. And we'll get to that in our Zoom class. When you're doing your document, you can take a screenshot. You just click the little camera icon, and it copies it to the clipboard, or you can right click on it, copy image, and then you can go into your document and you can paste it wherever it says insert or draw a picture. Like right here, draw a picture. You can just go in here and you can paste that image in there, and then it goes into the document. Okay? So that is our magnetism. It should be really straightforward. It should really be a review of things that you've probably heard before, all the way back to elementary, but we got to have that common language before we get into this. So this is going to be video notes on electromagnetic induction. It's how basically a magnetic field, if it's moving, it can cause electric current in a wire. But the flip side, a current in a wire also creates a magnetic field. And using that principle, we can actually use electricity to create a motor or a generator, an electric motor or an electric generator. So that's what the second video is going to talk about, is motors and generators. And the notes appear really simple, but the concept on one hand actually is, but it's fascinating because there are millions of everyday applications, like your headphones, your speakers, your cell phone uses this induction principle all the time, or it wouldn't work, okay? You wouldn't have electricity without this principle of induction. All right, so you'll take notes and study that. Then you'll have a second gizmo, okay? And so this one isn't an Explore Learning gizmo. This one's, you're going to use the links inside the document. You're going to just go to the link here, Faraday's Law Simulation, click on that simulation. You'll have to click play, let it load. And basically it's cool because you can have the field lines drawn for you. So field lines always go from north to south. And then I can move the magnet. Now watch what happens when I move the magnet to the light bulb. So if I go towards the light bulb, you can see how the voltage works. I can flip the magnet and I can move it towards it. Notice the arrow went the other direction because the field lines are pointing in a different direction, okay? But you can also basically rotate the magnet is what you're simulating. And by rotating the magnet, you are basically generating electricity because you're rotating it inside of this coil of wire, okay? So you're changing a magnetic field next to this wire, and it's causing the electric current in the wire to flow, and the electric current goes through the light bulb and lights it up. And that's how electricity in your house is created. You have giant magnets spinning an electric coil, or electric coil spinning inside a magnet. It'll do the same thing. Now, you can also switch to 2 different coils. So we can sit here and you can see how bright that light bulb is with 2 coils. And then we can move it down here and put it in the bigger coil and notice how much brighter it is. So the number of coils, the bigger the effect is actually, okay? And electrical engineering term for coils is windings. And on an actual motor or generator, you could have 500 to 1,000 or more windings around something, okay? Let's see. The questions are pretty straightforward, so please read it carefully and read the directions here. Highlight the correct answer or delete the wrong answer. So I basically have given you the sentence. So whichever one is the correct answer, you can just highlight it. Just go up here to the highlighter and click highlight, okay? Or you can just delete whatever part of it is wrong, Okay? So it's a fairly simple and straightforward, but it's super important concept in physics. Once you finish that, we will have our final Zoom of the year, and we will talk a little bit more about induction and celebrate our success, and hopefully give you some more work time to do the gizmo and do this feedback survey. So when you click on the survey, there's going to be it's going to ask you for your name. Make sure you put your first and last name. Then it has some rating. So if you didn't do this or use this, there are some things like this weekly overview video, for example, that some people did not watch at all. There are some of you that maybe watched a minute of it. There are some people that watched all of it, and it was very helpful. So you're going to rate, did I even use it? Put a 0. If I really liked it, then I will put what that rating is, okay? There are also several places where I allow you to put comments. Most of those are optional. But if you have something specific, the more specific you can be, instead of just saying, oh, that was great, keep doing it, or I didn't like it, don't ever do it again, that doesn't help me. Why did you not like it? What about it made it not work? Because for some students it does work, and it may be I just need to change part of it. So the more specific you can be with this, the better. And then there's a section here at the end where you're going to rate yourself. Did you actually plan? And be honest, if you didn't actually use your planner, then tell me that, because you need to tell yourself that. So be honest with yourself, okay? But it also tells me how you're interacting with the course and helps me design it appropriately. Because even though next term we will be in person 2 days a week, I will be mostly delivering stuff online, and I need to make it better than it is. So thank you, and I appreciate your feedback on the survey. Oh, and not on the list, there will be a quiz. It will most likely be a vocabulary catch-all about electricity, magnetism, and induction. So it shouldn't be too difficult, but you will have a short quiz. And then the last day will be a catch-up day to get everything turned in. Hope the rest of your weekend is great, and I hope you have a great week. And I will see you on Tuesday or Wednesday or during tutorial time. So don't forget to take advantage of any tutoring this last week to help yourself get caught up, all that good stuff. All right, thank you. Bye.